Welcome to Module 2, Lesson 21, If-Then Moves with Integer Number Cards. We are actually going to take a different approach to this lesson. So let's go ahead and turn to that first page in your binder. I will scroll on back to that first page. That is right there. So I'd like you to do this with a pencil because maybe we might want to do something later on with this. But for now, I want to do this. Okay, we're not going to do that. Next page, don't worry about that. Next page, don't worry about that. Next page, don't worry about that. Next page, lesson summary. Let's start from there. Okay, we are actually going to this lesson would play out much better in a classroom, and I looked it over. I'm not quite sure of the value of it. I know what they're trying to get across, so I thought I might just go ahead and talk about this. Just do the lesson summary with you, just to get across those points, and to go ahead and do the exit ticket together. Okay, which I think would be a more of a might work better, and it's going to make this lesson really short, which I'm sure is going to overjoy everyone. Okay, well, here's a lesson summary. So let's start from here, okay, starting from the end here. But here are the statements they want you to understand. These are the things they wanted you to understand. These are things we've actually been doing, and we've been talking about since probably since the beginning of the year. But now with this lesson and in the coming lessons, we will be more direct in approaching this. So, lesson summary here. So, if a number sentence is true, A equals B, okay, and you add or subtract the same number from both sides of the equation, then the resulting number sentence will be true, okay. And you know what? It seems to just make a lot of sense. I have talked in the past about this idea of a balance scale. Okay, so if I have A plus B, okay, and then A plus B, all right, they are balanced. Okay, if I add a C over here, I am going to tip that balance, and it's going to tip this way. So what I need to do is I need to actually add C to that side as well, and again to balance it. So whatever I add from either side, and for example, if we just don't use A, B, and C, we could just use integers like they actually did in this lesson. Let's say we had -1 plus 3 plus 2. Okay. And what do we have there? We have 5. We have 4 as a total. Maybe on this side we have 3 plus 0 plus 1. Okay? So we have both sides equal 4. Therefore they are equivalent, or they are balanced. Okay? They equal each other. All right? Now, if I remove 3, what I'm doing here is I'm going to add a -3 to this side. Okay, I am then left on this side with 1. Okay, because I am removing 3. All right, now I have 1. I have to do the exact same thing over here. Okay, and therefore 0 plus 1 equals 1. I have to do the same. Whatever I do to one side, I have to do to the other to maintain my initial balance. Okay, and that's what they're talking about, and that's what they mean by this. If a number sentence is true, A equals B, and you add or subtract the same number from both sides of the equation, the resulting number sentence will be true. Okay, and again, the next point here in the lesson summary follows. If a number sentence is true, A equals B, and you multiply both sides of the equation by the same number, then the resulting number sentence will be true. Okay, so we can take the same balance scale, the same balance situation. All right, and make a new balance scale, and we can just talk in terms of multiplication now. All right, so if we had, let's say, 3 plus 4 on this side, okay, and then we had 7 on this side. All right, we know that they are balanced, they equal each other. Okay, so if I go ahead and multiply this whole side over here on the left by 8, okay, I'm going to multiply that by 8. I would multiply this by 8 as well. Okay, so 8, and I can distribute this. That's 24 plus, I'm doing 8 times 3, then 8 times 4, plus 32, which equals 56. And I know that 7 times 8 is also 56, and they are balanced, okay? So they equal each other. So if my initial number sentence is true, okay, 3 plus 4 equals 7, then I should be able to multiply both of those sides by the same number, which in this case I did with the number 8, and I should be able to get the same result, which I do. Okay? All right, and again, we will see this, and again, we've done this in the past when we've actually tried to, if you remember, we've tried to isolate x on one side or the other, and we've multiplied by the same number, and we've also done the next, which is dividing. So again, if a number sentence is true, a equals b, and you divide both sides of the equation by the same, in this case we have to add this idea, non-zero. Remember, we can't divide by 0. That is not an actual rational number. If you divide by the same non-zero number, then the resulting number sentence will be true. Okay, so if we had what do we have? We could just do I could do the same thing. 3 plus 4, equals 7. Same balance. All right. So if I divide both of those sides by 7, let's say, I'd have 3 plus 4 over 7, which equals 7 over 7, which equals 1. And then if I divide 7 divided by 7, that equals 1. And again, okay, well, it looks like I might have kept had the recording running while I was doing all of that. Okay, yeah, so are the two expressions equivalent? How do you know? And, well, you saw me write it down. Yes, they are. They both evaluate to the same number, okay, and they evaluate to 8, right? So, 6 plus 7 is 13, and then plus a negative 5, excuse me, negative 5 is going to be 8, and then the same down here, 10 plus 3 gives you the 13, and plus a negative 5 gives you 8. So yeah, they do. They are equivalent, okay, because they both evaluate to the same number. All right. So I'm going to click ahead here, a little more room on this page. Okay, so go ahead and do this, and I will pause this time. I hope. So here we go. We're going to subtract negative 5 from each expression, write the new numerical expression, and write a conclusion as an if-then statement. And when you come back, why don't you give that a whirl? We didn't really talk about those, but when you come back, we'll talk about them. But do what you can with this, and then come back. Okay, so I've written here the new numerical expression for both of these, and hopefully you didn't forget one very important fact, and that was that this was asking you to subtract a negative 5. Subtract a negative 5, and that appears right here. Okay, hopefully I'm anticipating that some of you may have just written minus 5. Okay, but they said to subtract a negative, which if you know subtract a negative also means add a positive. Okay, remember that? Hopefully some of you got that. I'm sure some didn't, and I now understand. Okay, a little more practice we need. So if we went ahead and reevaluated these, we know up to here equals 8. Okay, and all we'd have to do is now add another 5, because remember, subtracting a negative is like adding, so that's going to be 13. And we know this, of course, was 8 already, evaluated to 8. And now again, we're doing the same, and plus equals 13. So this idea of an if-then statement is this, plain and simply. It's like, if, I'm just using this section right now, if expression 1 equals expression 2, which it did, then adding, oh sorry, I wasn't adding in this case, but it is kind of, but then subtracting negative 5 from both makes them remain equivalent. Okay, so if you're going to do the same thing to two things that are already the same, then they're going to continue to be the same. Okay, so if expression 1 equals expression 2, if you do the same thing to both of them, from both, they are going to remain equivalent. Okay, and that's that whole idea with that with the lesson summary we just had. All right. So let me go ahead and just subtract all this off. Hopefully you had that down. If you didn't, why don't you go ahead and just go back and pause and write that down. Okay. So here we go. Now we're going to do something else. And again, this is what this whole lesson was pretty much about, was doing this just a number of times. So now what I want you to do is to go ahead and add 4 to each expression, okay, and write the new numerical expression and write a conclusion as an if-then statement. And this is the an exact same thing we just did. Okay, so I want you to go ahead and so you're going to ignore this part right here. So this is no longer just to the original expression. Take that original expression, the two original expressions, 6 plus 7 plus negative 5, and then negative 5 plus 10 plus 3, and go ahead, but this time add 4 to each expression. Okay, I'm pretty sure you got this one. Again, we knew that expression 1 and expression 2, they both equaled 8. They both evaluated to 8. And if you're going to add a 4 to this one and a 4 as well to this one, they're going to be equivalent. They're going to remain 12. And again, the if-then statement, it's exactly the same as before. If expression 1 equals expression 2, and you add the same number to both, they will continue to be equivalent. All right, here we go. Now let's go ahead and do number 4, and in number 4 you're going to divide each expression by -2. And again, write a conclusion as an if-then statement. This should be pretty clear to you what to do. So go ahead and get it done. Okay, again, so I'm starting with both expression 1 and expression 2 again. And just like before, just to make note that we know that expression 1 equaled 8, expression 2 equaled 8. Now if I'm going to go ahead and divide 8 by -2 on that side and 8 by -2 on this side, I know that 8 divided by -2 is going to be -4, because a positive divided by a negative is always going to be a negative. Same on this side. And there we go. If-then statement remains the same. If expression 1 equals expression 2, and you do the same thing, or you divide both by the same number, in this case, then your resulting answers will remain equivalent. Okay, well that's all I have for this lesson. 16 minutes have gone by. You can go ahead and take this time and do your problem set. If you end up having a little extra time, you could maybe go back or maybe move forward as well onto lesson 22. Alrighty, well thanks, hope you enjoyed this, and I hope this is somewhat clear to you.